Hey class, welcome to part 5. This time we'll be talking about how to measure lighting levels and lighting quality. So diving in, let's remember illuminance, the strength of light falling on a surface. We measure that in terms of lumens per square foot candles. We can also measure that in terms of lux. So 1 foot candle is 10 lux. And this is just the amount of light that is actually falling, hitting a surface. And we can measure that with a lighting meter. Most lighting meters that you purchase or might use are designed to measure the illuminance. So you can set it on a desk and figure out if the workers have enough light for their particular tasks. They're pretty simple. Here's one. All you have to do is basically turn it on. It's going to run through a little self-test. And now it's showing 0 lux. I can switch between lux and foot candles. I'm going to leave it in lux for now. And then I can take off this little black cover. And we can see how much light is falling on the desk. And it's looking like around 624 lux, 630. Cool. Well, now that we know that, what does that actually mean? Is that enough or not? So let's look at some standard values. All right, so a warehouse, you don't need a whole lot of light generally. So the recommended level, this is not code, these are just recommendations out of the IES or Illumination Engineering Society, I believe. Warehouse is on the lower level, 50 lux. Production line, so processing things, that's 500 lux. If you are actually visually inspecting items during manufacturing, reading labels and such, that is 1,000 lux. For office or typing, you'd be at 1,500 lux. So I was measuring, what was it, about 630 lux. So that's a bit low for office or lighting, but for me, this space feels very well lit. I feel like I have plenty of light. So a lot of it comes down to personal preference. And these are just guidelines, and they can really vary by 50% or so. So for office typing, it can be all the way down to 750, or in my case, around 630, or up to, say, 2,000 lux. Once again, these aren't code levels, but if you walk into a warehouse and you're reading 2,000 lux, you know that you might be able to get away with using fewer lights and still get the job done. So keep a hold of these values. And if you're measuring it in terms of foot candles, it's pretty easy to just reduce the value by a factor of 10. So 50 lux is 5 foot candles, 1,500 lux is 150 foot candles. All right, so good things to reference as you are doing some energy audits. The other thing we can measure, of course, is luminance. And this is the strength of light that is measured directly. It's light that is directly hitting the eye. We measure that using a luminance meter. This looks like basically a little ray gun, and it works just as you expect. You can take off the cap and point it at a bulb, and the brightness is measured in terms of candelas per foot squared or candelas per meter squared. Now, there aren't any official guidelines for glare. If there's a really bright spot in the office, people are aware of that, but there's no code mandate against it. What this is very helpful for, though, is measuring the strength of an actual light bulb and how that light bulb is performing. Because over time, light bulbs will degrade. So here's a graph of a high pressure sodium bulb. This is a cut sheet just taken from a typical lighting supplier. And you can see as the light bulb ages out, the amount of lumens that it actually outputs falls with time. So you can use one of these meters to determine where that bulb is in terms of its initial performance versus its actual performance. And that's something that's important to know if you're doing any upgrades or life cycle cost analysis is considering the spec sheets of different lamps. So let me actually pull up a couple of spec sheets just as an example. All right, let's minimize this and zoom in. All right, so in this particular example, we've got a high pressure sodium lamp. This is just online from Howard Lighting Products. And you can see it is designed to give off 400 watts. And the initial lumens that it produces is 51,000 lumens. Now these lumens, once again, they might go off in a whole bunch of different directions. So to actually measure the illuminance falling on a surface, that's when you would use a light meter. Over time, of course, it degrades, and so the mean lumens it gives off are 45,000, and it has a rated life in terms of hours that it's on of 24,000 plus. So a little over 8,000, closer to 9,000 hours in a year. We're guessing this light bulb might last, 3+ years. And over time, it is going to degrade. And some of the light bulbs might even fail earlier than its expected lifetime. So if we were to replace this, let's look at the other piece, is the color temperature, right? 2100 Kelvin. So if we were to look back at our chart, let me find the correct slide. Let me pause here for a moment. All right, now we're looking at the right chart. So the spec sheet said that the light from the high pressure sodium bulb was giving off 2100 Kelvin. So that's a very orange light. Now, if we wanted to replace that, I've got a spec sheet from an LED bulb. Now this one, oh, come on, computer. Now this LED light replacement, its specifications show it only draws 150 watts. It doesn't produce as many lumens, it only produces 15,000, but it might still produce the same amount of illuminance on the surface since those LEDs are so directional, whereas the high pressure sodium might be casting those lumens in a range of different directions. And its color here is at 4,000 Kelvin. So let's look back at that chart. 4,000 Kelvin, we're looking at a much brighter, kind of a cool white, as opposed to that sodium, which was that very orange color. So it might be a really nice upgrade, it might not, but those are the factors that you're going to be looking at in terms of replacing a light. All right, so a recap on this quick unit. You measure illuminance using a light meter to make sure that there is enough light on the surface for people to complete their work tasks. You measure luminance, or the amount of light that's being emitted from a surface, using a luminance meter. And you need to look at the spec sheet for the actual bulb as well as the ballast to see if it is going to produce somewhat comparable luminance as well as color spectrum. All right, thanks for joining and see you next time.